In this lesson, we'll be discussing how automaticity relates to the assembly and automation theory, and our objectives for the lesson are to examine and understand how automaticity of a skill develops through the process of unitization and chunking. Here you can see various ways we might identify words, and although these words may be familiar, research indicates that the vast majority of words are identified through memory or sight. We have what we call a large mental lexicon that may have hundreds of thousands of words in it so that we can identify them with high efficiency, if not full automaticity. Now let's take a look at a comparison of second grade readers who are more and less skilled readers. And if we have them identify a digit like 8 in this example and measure how quickly and automatically they can identify that digit, you can see they do it in about 0.9 seconds. But when less skilled readers try to identify real and common words such as cat, they can do that in about 1.1 seconds. Now, if you compare that to the skilled reader at the same grade level, you can see that they identify digits and real words at the same rate. So they identify the digit 8 as quickly and efficiently as they would identify the word cat. And what this indicates is that students who are efficient readers or highly skilled readers, those who are meeting the standards for reading achievement, are not relying primarily on decoding or analogizing or prediction. They're relying on their large mental lexicon that they've begun to develop in order to have a high level of automaticity that facilitates reading comprehension. Now, when you look at the difference between readers who are less or more skilled, you can see that the less skilled readers take substantially longer when reading non-words, which is directly related to the skill of decoding without the interference of top-down or meaning-based processes. So overall, these results indicate that as we become increasingly more proficient readers, we don't rely on decoding as our primary mechanism. We read whole words that we know by sight. Now, the English language is made up of rules that allow us to build our mental lexicon much more efficiently. Research indicates that early instruction in alphabetic skills and decoding functions as a schema or a facilitator of the development of these mental lexicons. And children learning to read English do not limit themselves to processing words one grapheme at a time, but instead they adopt this flexible unit or size strategy, complementing our synthetic phonics with attention to things like rhymes, that's R-I-M-E-S, syllables, and whole word patterns, and these are the varying units of grain size that researchers typically write about. The significance of automaticity is indistinguishable without recognizing this psycholinguistic grain size theory because the theory emphasizes that automaticity can occur at different levels or units. And granularity here refers to the idea that there are many orthographic units available to a child who's learning English. According to the psycholinguistic grain size theory, young learners of relatively consistent languages, those that can have a letter that immediately maps onto a single sound, so one letter equals one sound, the child focuses exclusively at a small psycholinguistic grain size, and they're able to make very few errors when they make that connection. English, however, is an example of a deep orthographic language because one single letter can make several different sounds. Instead of a distinct one-to-one correspondence, it's a one-to-many correspondence. So children are required to kind of find those grain sizes in the symbol system, the orthography, and the phonology of their language. Researchers, including Brown and Devers, have shown that children learning to read English don't limit themselves to processing words one grapheme at a time or one phoneme at a time, but instead adopt that flexible unit size strategy that complements our synthetic phonics with attention to rhyme syllables and whole word patterns. Now, according to the psycholinguistic grain size theory, young learners of consistent language, where there's a direct one-to-one correspondence between a letter and a single sound, they can focus exclusively at a small psycholinguistic grain size of the phoneme without making many errors. However, English is a language in which these correspondences are inconsistent. In English, the letter E can map onto several different sounds. This is considered a deep orthography because there aren't consistent one-to-one correspondences between a printed letter and a sound. In English, beginning readers have to learn additional correspondences for larger orthographic units such as syllables, rhymes, and whole words. And these are typically the basis for decoding in the early grade levels, these skills that facilitate the developing reader and help them establish these systematic patterns in the language. And these patterns allow automaticity to develop. And then as automaticity develops, the size of the visual unit that must be held in short-term memory increases up to that level of the meaningful word. So eventually they're reading a whole word instead of individual components of those words. Now, some people have talked about this process in terms of unitization. This can begin at the letter level, where we unitize the association between the shape of a letter and the sound of the letter. Then we'd unitize at the subword level with common letter combinations like sh or ing. These things need to become automatic, so we're not using our cognitive resources to try and decode and identify words with these small individual units. Then we begin to unitize at the word level, including the shape, sound, and meaning of the word. And it's important to recognize that automaticity will not only be related to the shape and sounds of the words, but also to their meaning, which I'll illustrate next. So take a moment, pause the video if you want, and try to read this text. Now, as established readers, we can all read this. And to show you, well, here goes. According to research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letters be at the right place. The rest can be a total mess, and you can still read it without a problem. This is because the human mind does not read every letter by itself, but the word as a whole. Now this phenomenon, now notice I had to hesitate a couple times there, but this phenomenon shows that as long as the first and the last letter in each of the words is retained, and there's a similar number of letters in between, we can usually identify the words. And this is because we are top-down readers. Proficient readers have this large mental lexicon, and they're trying to match the visual stimulus to what they have already stored. It's not just letter-sound relationship in each word that we're using to read, it's the meaning of the words. So another example that focuses on meaning is the Stroop task, which you may be familiar with. Somebody might say, name the colors of the letters you see. And this task is difficult for those of us who are established readers. Now, for emerging readers who do not read or understand this word automatically, it's easy for them to say the color of the letters. They're red, even though the meaning of the word, green, conflicts with the color of the letters. That's what makes it uncomfortable for skilled readers to look at something like this, because there's that dissonance between the meaning of the word and the activity that's they're being asked to do. Now, if we see this, it's a much more comfortable task, and it's easy for us to identify the color of the letters because the meaning and the activity of naming the color of the letters correspond with each other. Now, the automaticity of the word green is greater than the automaticity of color identification of the letters. Let's illustrate this in one other way. So here's an illustration of a semantic net. Our mental lexicon is not just lists of words like a dictionary. Instead, it's more similar to a thesaurus. So if you hear the word fire in your mental lexicon or semantic net, the word fire creates activation potential so that when you see the word fire and maybe the word truck, or fire in the word red, or fire in the word yellow, the speed at which you're going to identify the word truck following the word fire is faster. It's related at a direct and higher level to truck than it is to red, yellow, or orange. We get faster at word reading because this kind of activation is taking place, and all of this is observed when you're listening to students read aloud, when they're doing their CBM reading activities. So automaticity relates to the printed word, but it also relates to the sound the word makes and the meaning of the word. Then we connect the meaning of multiple words so we're able to store that information as chunks of information and optimize our cognitive capacity, so we're reading chunks of meaning when we're reading a text. And all of this is important to be discussing because we're moving towards understanding that oral word reading is used to evaluate whether or not automaticity has been established. Improved oral word reading indicates improved orthographic, phonological, and meaning or semantic-based processes. And these help us determine if automaticity has been established. So let's recap some important things from this lesson. We discussed how automaticity develops at grain sizes and relies on unitization of words. Also, the phonemic and orthographic knowledge that we use are powerful mnemonics that can help children unitize information, and that unitization and automaticity occur with exposure and practice to reading connected text, and teaching students high frequency or sight words help them begin to access connected text. Also, unitization and chunking allow students to gain that cognitive capacity so they can comprehend what they read. And automaticity involves not just the sounds of the word, but also the meaning. So when we listen to a student read aloud, they're accessing both of these things, not just decoding the words or reading so quickly they don't understand it, but both meaning and the word sounds. Finally, oral reading is an excellent indicator of generalized reading performance, which we'll continue to discuss in the next video. In part 3 of the unit on automaticity, we'll discuss the phases of skill development and implications for instruction. Thanks for watching this video on assembly and automation theory, and be sure to check out the next one.